Page 179, problem set 44. Problems that you want to go over.
Oh yeah.
175.
Everybody got all of these right?
You went too fast. I didn't understand.
Can you do 13?
Yes, number 13. Solving for y. 13, 3y
Oh.
minus 2x minus 7 equals 0. Now, when we have two, that's just how this works. So we want to get y by itself because this is solve for y. So to get y by itself, what should we do first?
Add 7.
Add 7, what else?
Then you're going to add 2x.
Yeah, and add 2x. Okay, so we've got 3y equals what?
7 plus 2x.
Yeah, 7 plus 2x, or 2x plus 7. Now what do we do to get y by itself?
Divide by 3 on both.
Divide by 3. So what do we get? Y equals?
9x. Oh, 3x. I don't know.
Can we simplify this at all?
No.
No.
Wait, is it okay? Like, I have that same answer, but I have 2x in front of 7.
Yeah, that's fine. You got to write 7 plus 2x plus 7. Addition has the commutative property. Order doesn't matter. So there's nothing we can simplify here because notice these two, they're not like terms, so we can't combine them. This has x, this one doesn't, so we can't combine them. We also can't undo this addition with division. We can't divide anything out. And there's no common factor between 7 and 2x. So we can't divide that out either. 2 and 7, what's the only factor that 2 and 7 share in common?
14.
Factor, not multiple, factor. What's the only thing you can divide them both by that they share in common?
None.
1, yeah, which isn't going to help us. How can we tell? By the way, what's an easy way to tell that 2 and 7 have no factors in common?
Prime number.
If you add them up.
They're both prime. They're both prime. 2 and 7 are prime, which means that their only factors are themselves and 1.
And 3.
You did it.
Yeah, but yeah, I guess 3 is also prime. So there's nothing in common between any of those values there. Next.
Could you do? Wait, what one did you do?
We're just at 13.
Oh, yes, the
Would you 11?
Number 11. We're solving 11. Solving for p. 5p minus 6 times 2p plus 1 equals negative 4p minus 2. What should we do first in order to solve this?
Oh, God.
parentheses.
Get rid of the parentheses. What's going to happen when we get rid of the parentheses?
5p minus 12p plus 6.
No. Minus 6.
That's negative.
Remember, because of this subtraction here, what we really have is plus negative 6 times this.
Yeah.
When you have subtraction like that, the negative sign distributes out also.
Yeah.
There was a problem on the test that was kind of similar to this that a lot of guys got wrong for this reason, or for a similar reason.
Yeah.
So really, when we say minus 6 times this, it means plus negative 6 times that. So we have to distribute the negative out also. And then on the right, we have negative 4p minus 2. What do we do now?
Alright, then you're going to add like a term.
Combine like terms. What do you have on the left once we combine like terms?
Negative 7p.
Negative 7p.
Negative 7p minus 6 equals negative 4p minus 2.
All right, now what do we do?
Add 6. Yeah. And
Yeah.
then add 4p.
Yep. So move the variable to the left by adding 4p to both sides. Move the constants to the right by adding 6 to both sides. Now what do we have?
Negative 3p equals 4.
Equals 4, so p equals?
Negative. Yeah, 4. Negative 3.
Yeah, 4 over negative 3. Or you could write negative 4 over 3 or negative 4 over 3, whatever. Yes? So be careful with the distribution when there's subtraction. That's why I say, this is one of the many reasons why I say that I don't like subtraction. I like adding negatives. Remember that subtraction means adding a negative. And that'll help you with this kind of distribution here.
What if I have the negative sign on 3?
You do,
That's fine. Yeah, when you have fractions, the negative sign could go on the top, it could go on the bottom, it could go in front of the whole thing. I prefer to put it on top, but doesn't matter. Yep.
What if I put it on the bottom since it's 3?
Yeah.
or 15.
15?
Oh, yeah.
Yeah, least common multiple of 8, 30, and 75. So 15, we want least common multiple of 8, 30, and 75. So what do we need to do first? To find either a greatest common factor or a least common multiple, either one. What do we need to do first?
Factor them out.
Break them down into what?
Prime.
Prime factors. So 8 is going to become what?
2,
2 and 4, which then becomes,
2,
okay, so 8 is equal to 2 cubed. That one you should know. You should just know. You should know the powers of 2 up to like 2 to the 6 or something. Okay, 30,
15 and 2.
15 and 2,
3 and 5.
and then 3 and, whoops.
What is 2 to the 6?
What was that?
What is 2 to the 6?
2 and 4.
What's what?
It's not.
2 to the 6
I'm asking you what's 2 to 4.
is 64.
2 to 4.
All right, so 30 is what?
2 times 3.
Yeah, and what about 75?
15
I said 25 and 3.
Oh, yeah, I would do 25 and 3. 75 cents is 3/4.
And then 5.
And then 25 is 5 times 5. Okay,
Alright.
70 is 3 times 5 squared, yes? Now remember, we're doing least common multiple. The least common multiple is the smallest thing we can multiply each one of these things up to.
2 times 3 times.
That was quite a defense of the language intro.
Thanks. So it's going to have to involve 2.
3 times 5.
It's going to have to involve 3, it's going to have to involve 5. But we don't know which powers of those we need.
Yeah.
Well, not yet. So what power of 2 do we need?
3.
2 to the 3rd. For the least common multiple, we need the largest that we find in any one thing. Because it's easy to multiply 2 up to 2 cubed. We just multiply it by 2 squared. This one has 2 to the 0, so to speak. Right? It's easy to multiply 2 to the 0 up to 2 cubed. Okay, 2 cubed to 2 cubed, which is multiplied by 1. What power of 3 do we need?
9.
1.
3 to the 1st. This one has 3 to the 1st, this one has 3 to the 1st, this one has 3 to the 0. So the highest power is 3 to the 1st. And what about 5? We need 5.
Square.
5 squared. Okay, then if you wanted to multiply that out, you get 8 times 3 times 25, which will give you what?
That one.
Well, what's, say it again? Yeah, it's 600. I think the easy way to do that, 8 times 3 times 25, is you do 8 times 25 first, which is what? What's 4 times 25?
200.
Yeah, 4 times 25 is 100, so 8 times 25 is 200, times 3 is 600. Now, what if we want to find the greatest common factor? What if we want to find the greatest common factor, the biggest thing that they all share in common?
Oh, that's that one.
Oh, no, you would do
Two,
it.
three, and 5.
2, 3, and 5.
No. Yeah, it is.
We want the biggest thing that they all share in common.
2, 3, and no.
2 to the 3rd power.
Hold on a second. Oh, I wrote 70. So they should be 75. What's the biggest thing they all share in common?
I don't think they share any of them.
Yeah, so what's the biggest thing they share in common?
2.
No, this one doesn't have 2 as
They
one of
don't
its
share any
factors.
in common.
3.
So this one doesn't have 3 as one of its factors. So what's their greatest common factor?
0.
No.
Unknown.
What's the greatest common factor?
75.
What number can you always divide anything by?
2. 1.
Thank you. Yeah, the greatest common factor is 1. There is no number. There is no number, weirdly, because each of these numbers has plenty of factors. Weirdly, there's no number greater than 1 that all 3 of them share as a factor. But that's just the way that it is.
So,
Whoa.
least common factor, I see them all broken down.
Yes.
What do you do?
Sorry, which one? Least common multiple or greatest common factor?
Least common multiple.
Least common multiple, we look for each one of these factors. Each prime factor has to be represented to the highest power that it is in any particular number. So because 2 appears as a prime factor, we got to have 2 there. And not just 2, but 2 cubed. Because this is a multiple, so we're multiplying these numbers up to it. It's easy to multiply 2 up to 2 cubed, but we can't go the other way around. So we have to represent 2 cubed there. 3, there's only 3 of the first in any of them. And then 5 squared because there's a 5 squared there. So you have to have each prime factor represented to whichever is the highest power that it appears in any number. The greatest common factor, you're looking for which prime factors do they share in common. Basically, what the least common multiple is it's a combination. You're combining the prime factors of all of them. So ask yourself, is 2 cubed in here? Yes. Is 2 times 3 times 5 in here? Yes. Is 3 times 5 squared in here? Yes. That's what we're doing for the least common multiple. We need to make sure that every single one of these things is represented there. We don't need 2 to the 4th because 2 is already represented in 2 cubed. And we're looking for the least, the smallest. Okay, you need to make sure everything's represented. Yes?
We also do
16.
It's similar, but it's with variables.
Yes, so yes, the 16th, similar idea, but with variables. So 16 here, we're looking for least common multiple again. Least common multiple of
4w squared y cubed
That one.
and 6w y squared.
Okay, so here, when you've got literal components, when you've got variables and their letters, it doesn't really change it. We can still break them down, so to speak, into their prime factors. So 4w squared y cubed, what would that be if we break it down? What can we break 4 down into?
2
Not 2, 2,
w.
no.
2w squared y
Division
cubed.
out.
2 squared
Yeah, 2 squared times what?
times
Times w
squared
Which
is
squared?
times y squared.
times y cubed. Where do we get squared for what?
Where'd you get for 2?
4 squared is 2. 4 is 2 squared,
The square root of 4.
right? Because if we do this to 4, we get 2 times 2.
Yeah, I got it.
Yeah, okay, that's where we got that from. All right,
Can I go to the bathroom?
once we finish this problem, 6wy squared breaks down to what?
3 squared.
Three.
Oh, no.
No.
Not 3 squared. 2 cubed.
No,
Oh, wait, I'm done.
8 is 2 cubed. What is 6? 6 is 2 times,
3.
yeah.
Oh,
Yeah, 3.
That's 2 times 3 times what? Times what?
Huh?
2 times 3 times what?
W.
Times w times
Y squared.
y squared. Same deal for the least common multiple. We need to represent every single one of these things in here. So we need to make sure 2 squared is represented.
2 squared.
We need to make sure
Times 3.
3 is represented.
Times
Wait, what about this 2? Is that 2 represented?
No, we don't need that.
Well, we need to represent it. Is it represented already?
Yes.
Where?
That's 2 squared.
Yeah, the 2 is already represented in the 2 squared. All right, so we've got everything represented there. What about with these w's?
W squared.
W squared
And y cubed.
and y cubed. Notice with the variables also, if we use w squared, that represents w as well. And if we use y cubed, that represents y squared as well. So it's 2 squared times 3 times w squared times y cubed. Usually with these, we'll multiply them out. So what do we get there? What's 2 squared times 3?
12.
12 times 12 what?
12w squared y cubed.
Yeah. These ones you don't always need to break down like that because with the variables there, you can just look at them because you've already got the power. So all that you need to figure out is what's the least common multiple of 4 and 6, which is 12. That's not too hard to do by hand or in your mind, yes? Because you just double 6 and that gets you 12, which is divisible by 4. And we look at w squared and w, and so we know we need w squared. And we look at y cubed and y squared, and we know we need y cubed. So when you've got things like this with variables in there, You don't actually need to break them down the whole way like these guys, but it's the same process. We're making sure that we're representing everything in our least common multiple.
I'm gonna go potty now.
Great. Next.
I can wake up.
Next. Time for maybe one more. Then I'm going to get the. I don't even know what that is. 17. Okay, 17. What do we have in 17?
2x plus m
But what kind of things do we have in 17?
numbers and variables.
But what kinds of things are we adding together? Let me ask.
Fraction.
Fractions. What do fractions need to have for us to be able to add them together?
The same denominator.
The same denominator. Do these fractions have the same denominator?
Yes.
Yes. If fractions have the same denominator, how do we add them?
Yeah, add the numerator.
We keep the denominator the same and we add the numerator together. So the denominator is going to be 3x squared m, and the numerator is going to be 2x plus m plus x plus 3m.
Okay.
If we simplify that by combining like terms, what do we get?
We get 2x squared plus 3m, no, 4m.
Well, be careful, not squared, because we've got 2x plus m plus x plus 3x. A squared is only going to happen if we multiply. What happens when we add 2x and x? What do we get?
Huh?
What happens when we add 2x and x?
3x.
Yeah, we get 3x and m and 3x. Sorry,
Oh, 6x plus.
no, sorry, there should be 3m.
Oh, yeah.
And what happens when we add m and 3m?
4.
Yeah, 3x plus 4m,
Over 3. Wait, which one is it?
x squared.
3x squared m.
Yeah. Now, at this point, you should ask yourself, can I simplify this?
Yes.
Yo, why are you guys sleeping?
No, sir, I'm listening. I'm gonna be the long.
You're back.
I'm really listening.
You're back. You gotta take this off your desk.
I'm sorry, but my dog woke me up at like 3 or 4 in the morning to let him
You
out.
tried having children?
Yeah.
All right, listen, but when you get to this point, you should ask yourself if there's any simplification that we can do.
Let me check.
Is there simplification we can do? Well, can we combine like terms?
Yeah.
Hey, you can do that thing that we do.
Which ones are like terms?
You can do that thing that
2x and x.
We do that.
3x.
No, we can't add 3x and 4m. There are no like terms we can combine.
Add 2x.
Yeah, that's what I meant. Yeah.
Yeah, we already did. We added 2x and x, we added m and 3m. We got 3x plus 4m. We can't combine like terms at all.
Yeah.
So then the question is, can we do any canceling out between the top and the bottom? Maybe by finding the greatest common factor of 3x and 4. What's the greatest common factor of 3 and 4?
1.
Oh,
1. Greatest common factor.
4. Wait, no. 1.
1.
he said that.
That's not going to be helpful. And m and x aren't in common. So we could do this. 1 times 3x plus 4m
Divided by 17.
over... What are you doing? You're making stuff up.
That's what I said.
guys, we should get fart bombs and things.
One factor of 1 doesn't do us any good. There's no simplification we can do on this. All right, let me get the tests back.
Isaiah, why would you say that? That's so rude.
I'll give you guys some statistics on these. These were okay, not great.
Wanna make babies?
One by third. I said you're the bar killer.
I'm the vibe killer. I am the vibe.
Bro, you're the greatest.
Don't.
It's just Sodom, bro.
That's their mouth. I'm not dead.
Yeah, sure, bro. That's what you keep trying to convince yourself.
You literally are in a group chat where you guys send pictures of each other's butts.
Bro, that was
Hey.
No,
that was not in that group chat.
Okay, yeah.
You know who screenshot that? Marcos. So if you want to go complain to him and his actually gay brother, you can.
Oh, shoot.
Oh, you're wild.
He exposed. Nah,
Yeah,
it's not.
yeah, I was never-
All right, so these were not great. They were not terrible on average, but they were definitely not great.
Yeah, Aston. It's my score.
Let me tell you the average.
got like a 7.
The average on this test was
So, like, if I try to test correction.
was a C. Was a C. But the distribution looked kind of like this.
No, it's alright.
Wait, no, not big.
Looked kind of like this. So like
It means that we did terribly. That's what it means.
so that's not so great. Please, if you are yeah, we just need to work on this. We need to work on this.
Yeah.
I'll be here after school today because it's Tuesday. I'll be here 2:45 to 3:45. You can ask me questions. Also during class time, you can ask me. We can go over some problems now, or we're going to, and corrections. Let's say by the end of the week. Yes,
So, wait, how do corrections work? How many points do you get back?
half.
How does that work with 3? Just get 1.5?
So, well, if there's like 2 3s, then you get 3. What I do is I count up the number of points that you lost on the problems that you do corrections for, and then I divide it by 2. So it's like a 3. Then 2 of those will get you 3 back.
So I can start with test questions tonight.
You could get 1 back.
So if we only have 1 3, there's no point in doing
Well, you could get 1.
it.
Can I start with test corrections tonight?
No, but you can give them to me tomorrow morning or
I'm not
by
gonna
before you leave today.
I'm not gonna be here tomorrow.
Before you leave today. All right, so there are a few problems that I noticed issues with. Let's talk about those. I'll pull out my notes here. All right, first up was number 5. First up was number 5 with the square unit conversions. I'm not going to do it on the board, but remember with square units, you need to do each thing twice because square meters is meters times meters, and so you need to do that conversion from meters to centimeters twice, and then you need to do the conversion from centimeters to inches twice. Right? Both an inequality and a negated inequality. Any kind of inequality, there are at least 2, well, usually exactly 2 different ways to write it. I'm not going to tell you exactly what the answer was there.
Correction rate in the same box.
You can do the corrections in the same box, but make sure there's some way that I can tell what's correction and what isn't. So if you did the test in pencil, did the corrections in pen, or use a different color, or do them on a separate sheet or something. So just make it clear to me. It's got to be clear somehow what's corrections and what's not. If you want to use the leftover boxes at the end to do your corrections in, that's great also. Number 10. I was surprised, well, not so much surprised as, because this is something that is just commonly an issue. You have to be careful with these negatives and with the negative exponents. Notice that with A, there's a -3 in parentheses and there's another negative sign outside of it. If you canceled out the negative inside the parentheses and the negative outside of the parentheses, if you did that first, that was a mistake. Why?
Because you did the first.
Well, there's nothing to do inside the parentheses.
You use the exponent on the parentheses.
Right, the exponent has to be used on the thing in there first. So first we take -3 and we raise it to the -3 power. What does it mean to raise something to the -3 power?
Negative fraction.
Make it a fraction with what, where?
The one with the exponent on the bottom.
Right, so it should be 1 over what?
Negative
27.
3.
Yeah, 1 over -27, because -3 cubed is -27. And then you make that negative again, so your answer will end up being
27.
no.
So make it negative again.
No. What did we just say it was? Once we
Yeah, negative 27, make it negative again.
No, I did not say it was 27. Remember, it's -3 raised to shh. No, you need to listen.
Alright.
-3 raised to the -3 power is what?
-1 over 27.
Yeah, -1 over 27.
Mm-hmm.
So then when we make that negative, it becomes what?
Fraction.
Positive what?
Exponent.
Wait, what?
Wait, I'm confused.
What question?
Yes, I can tell. We're on 10.
I need to use the bathroom, please.
Hurry up.
Oh, it's 1 over 7. No, negative 27.
First, we deal with the exponent. So, how can we rewrite negative 3 raised to the negative 3? How can we rewrite that? Anybody?
Negative 3 raised to the negative. Alright, so 1 over.
Plus 3. 3 to the third time.
It's negative 27.
Yeah, no, it's 1 over 3 to the third.
1 over, not 3 to the third,
Negative.
negative 3 to the third.
No, because
Yeah, it's there.
Why would you
So
put
we're
it
just
there?
gonna, if he did it, we could do it before and make it positive.
With this one, it happens to work out because we have an odd exponent.
Why did you put it there?
Why did I put it there though? Because first, we do the exponent, then we do the negative.
Oh.
First, we do the exponent, then we do the negative. So what happens with negative 3 raised to the third power on the bottom of this fraction?
1 over negative 27.
But there's still a negative sign there.
So, okay,
1 over positive 27, right. All right, what about B? 1 over negative 3 to the negative 3.
And flip it to the top.
Yes, we flip it to the top and it becomes what?
-3.
Negative 3 cubed. What do we do first? Put what in parentheses?
-3.
No, because it wasn't in parentheses to begin with.
So if it's an
So we do-
27,
Right, so we first cube it
then the negative.
and then make it negative. It happens with this one, whether you make it negative 3 and then cube it, with this one it happens to work out because it's an odd power, but if it were to the fourth or something, that would not work out.
Yeah.
Okay. All right, anyway,
It wouldn't work out.
what?
What do you mean it wouldn't work out?
So like imagine it were this, it will 1 over negative 3 to the fourth. Okay, let's try this 2 different ways. 1 over here, oh sorry, to the negative 4. So here first, you negative 3 to the fourth, moving into the top of the fraction. 3 to the fourth is, anybody?
3 to the 4. 27.
Ah!
Negative 3 to the fourth is 81. Right, it's 3 times 3 times 3 times 3. It's 9 times 9. Okay. Shh. That would be negative 81. Yes?
Yes.
Because first we raise it to the fourth, get 81, then make it negative. With this guy, we move this to the top, we get negative 3 to the fourth instead of to the negative 4. What's negative 3 to the fourth? Then it's-
Positive.
Then it's positive 81.
Yeah.
So you have to be careful. With this particular problem that was on the test, it didn't matter whether you did the negative first or the exponent first. But that will not always be the case with your exponents. You have to be careful with those. You do this in the right order.
Mr. O,
Yes?
so for less than the twice the opposite, that like 2 negatives and 2 n. For like number 4.
For number 4, so how do you say 24 less than something?
It's negative 24, right?
Well, yeah, so minus 24 or plus negative 24. Because 24 less than 100 is 100 minus 24. If I need to find 24 less than something, what do I need to do to that something to subtract what? Subtract 24 from. So what am I subtracting 24 from in number 4?
Twice the opposite.
Right. So twice the opposite is negative 2n. And subtract 24. All right. Next up is next one that a lot of issues were on with 13 and 14. With 13, they told you to put all variables in the numerator, so you should have just brought everything up to the top. But remember to flip the signs on them. So m to the negative 3, when you bring it up, becomes m cubed. B, when you bring it up to the top, becomes what?
B to the negative first.
Right, b to the negative 1, and a to the negative 2, when we bring it up top, becomes what?
A squared.
A squared, yes. With 14, I think most of the issues were simple. The way that I did this was I actually made all the exponents positive before I did anything else. So
No, not mine, not mine.
Oh,
But it should be other way. You should be
But-
running.
But when you did this, you would have ended up with some fractions that had x's on both the top and bottom and or y's on both the top and bottom, and you need to simplify before you're done. You shouldn't have a single fraction with x on the top and x on the bottom.
Yes, sir.
You shouldn't have a single fraction with y on the top and y on the bottom.
I understand.
Yeah, good. Next one there were lots of issues with were 17 and 18. 17 and 18. With 17, that's the one like I was talking about before. So take a quick look at 17. I'm not going to do the whole thing, but I will do the first part. 17, check your work here. We had 3 parentheses, 3 minus m, close parentheses, minus, parenthesis, negative 2, parenthesis, m minus 4, parenthesis, equals, negative parenthesis, 3m minus 2. What's the first thing we should do here?
Distribution.
Distribution. So what happens to this first term when we distribute? 9
minus
minus
3m
minus 3m. What about the second term?
plus 2.
Yeah, so we should, it's going to be easier for ourselves if we remember this is negative, negative 2, and to the negative 4. So it's positive 2. So what are we going to get here when we distribute this?
You're gonna get that one.
What am I going to get?
2m to negative.
Plus 2m
-8.
minus 8 equals,
Negative 3m plus 2.
yes, negative 3m plus 2. That was where I saw issues on this, was with the distribution.
You don't have
I got that!
And then you combine like terms.
Wait, for this one, I just like.
Oh no, I didn't. Never
I
mind.
canceled the 3m's.
Yeah, be careful because these are both negative 3m's.
Yeah, and then if you add on both sides, it'll cancel.
Oh, yeah, you can do that. Yep. Yes, you add 3m to both sides, and you'll get rid of those. And then you need to move then you'll have all your variables on the left.
You get 3 is equal.
And then you get, so we add 3m to both sides. What else can we do?
Add subtract no. Add 1 on minus 1 on both sides. There's 9 minus 8 is 1.
Okay.
And then you
Yeah, so we had 9 plus 2m minus 8 equals 2. Yeah, so then 9 minus 8 is 1 plus 2m
That one.
equals 2. Then we do what?
subtract 1. And you get 2. And then divide by 2.
You got that down.
1 half.
There you go.
You get that.
Sure.
Yep.
So number 14,
Mm-hmm.
you have to cancel them out.
You got minus 1.
Thank you.
It doesn't matter what order you do them in for 14, but it's possible, depending on how you do your canceling out, that your canceling out might result in some negative exponents, in which case then you'll need to flip them around to make them positive.
Wait, the test is on Friday?
I don't know what we're going to do about the test.
No, we shouldn't have it.
Yeah,
I would say at this point not to expect a test this week,
Yes.
because we're not going to do 47 today, so we wouldn't get to 48 before Thursday.
Skippy, Skippy.
And the test on the Friday half day before break just seems a little extra.
Yeah.
Okay, then 18. 18 again. It was similar issues with keeping track of your negative signs and using parentheses properly. So, and then of course 20. Lots of people not using the proper volume formula in 20. What's the formula for the volume of a right solid of any type? Area of the base times. Got to multiply those two together. Yeah, that was what I saw in this test. It's not the case that there were there were a few problems that caused issues. There weren't major issues in those problems, but what happened was that just there were a lot of different kinds of errors spread out across the problems in this test. So, you know, I think it's mostly a matter of more or better practice. Better practice, what that would look like is these homeworks, doing them more carefully, checking your work more carefully, asking more questions when there's things that you don't understand. More practice is easy enough to come across. You can go back and do problems from previous lesson sets. You can do the practice problems at the end of the lessons. Remember, in the lesson sets, it always tells you what lesson that type of problem comes from. So it's something that you struggled with. After you ask me about it, you can go back to that lesson and do the practice problems or work through the examples where they even show you how to do it. The practice problems, all the answers are in the back. So you can always check your work there.
Yeah.
We need to be making sure we're not making mistakes with things like negative signs, with simplifying fractions, with working with exponents, these kind of fundamental functional stuff. All right, other questions about the test? We can maybe go over one
Nugget
problem.
number 19.
Yeah, 19.
19 and 20?
Yes, Captain Sir.
Okay, so 20, you just have to find, the area of the base for 20 should be easy enough to find.
Yep.
Just break it into two
What?
rectangles.
Yeah, I did that, but I still got it wrong.
Okay, well how'd you break them into rectangles?
I got 4 and 13,
Okay,
and then I got 7 and 9.
yep,
And then I multiplied them, then added them.
yeah, so what'd you get for the area of the base?
115.
Yep, 115, but then what do you have to do? Area of the base?
Oh, sorry, 100.
Yes,
It was 11. 10 to 11.
no.
Times 18.
The height, remember, the height of a right solid is the distance between the two bases.
Yes, that's 18 right
Yeah, it tells us the height
Here?
in the problem.
there. No problem.
The base of a right prism whose height is 18 meters is shown. They tell you the height there.
Oh, they tell. Oh, wait, I'm gonna do that first.
Yep. For 19, notice its perimeter. The two straight parts are easy enough because they tell you the bottom one, the top one's the same because that's a rectangle there. And then for those two semicircles, really it's just two halves of one circle that have been moved apart, but the distance around the outside curved parts is still the same. Oh, thanks, Mr. O. You're such a helpful teacher. All right, thank you very much. Goodbye.
No.